There is a single blue flame burning in an Amish kitchen in Lancaster County tonight. No bigger than your thumb. It has been burning for 43 years. It costs that family less than $7 a month. And it keeps every drop of milk, every pound of meat, every jar of cream colder than the refrigerator humming in your kitchen right now. The one you are paying $40, $50, $60 a month to run. Stop and think about that. $7 a month. That little flame is doing something your electric fridge cannot. No motor, no compressor, no electricity, no monthly bill from the power company. The Amish have been using this exact method since 1922. The same year your grandfather was learning to drive a Model T, they never needed General Electric, they never needed a power grid, they never needed permission. The first time I walked into one of these homes outside Millersburg, Ohio, I spent 20 minutes looking for the hum. You know that hum. That low background drone every American kitchen has. It was not there. And when the old man finally showed me what was keeping his butter hard as stone in the middle of July, I felt something I had not felt in 30 years. I felt cheated. By the time I finish telling you what I learned from a 1,922 patent document and a quiet Holmes County farmer named Mervin, you are going to feel it too. And this works in the house you already own. Let me back up, because when I first heard about this, I did exactly what you are probably doing right now. I crossed my arms. I said, no way, a flame cannot make something cold. That violates everything I learned in high school. Fire is hot, cold is the absence of heat. You cannot burn your way to ice cubes. That is what I thought. Then I read about a man named Baltzar von Platen. He was a Swedish engineering student in 1922, working alongside his classmate Carl Munters at the Royal Institute of Technology in Stockholm. These two young men, barely in their 20s, figured out something that the entire electrical industry has spent 100 years trying to bury. They proved that you can use heat, a small, steady flame, to drive a cooling cycle that requires zero electricity and has zero moving parts. They filed the patent. The system was real, it worked, and by 1925, a company called Electrolux had bought the rights and started selling these refrigerators across Europe and America. Here is the part that should make every man over 50 grind his teeth. By the late 1930s, the American electrical industry realized this technology was a problem. A refrigerator with no motor lasts forever. There is nothing to wear out, nothing to replace, no reason to call a repairman, no reason to upgrade every 8 years, no monthly electric bill to feed it. So the marketing machine rolled in. Compressor fridges got pushed. The flame-driven absorption fridge was quietly shoved to the margins, to RVs, to remote cabins, to places the grid could not reach, and to the Amish, because the Amish never cared what General Electric was selling. They cared what worked. The principle is called absorption refrigeration. A pure liquid ammonia solution sits inside a sealed system. A tiny flame, the size of a pilot light on a gas water heater, heats one chamber. The heat drives the ammonia vapor up through a coil. As it rises and condenses, it pulls heat out of the insulated food box on the other side. The vapor cools, drips back down, and the cycle repeats. Forever. As long as that one little flame keeps burning. No compressor, no motor, no fan, no thermostat clicking on and off. Just one quiet flame, and the laws of physics doing exactly what Baltzar von Platen proved they would do in 1922. But here is what I did not understand until I sat at Mervin's kitchen table in Holmes County last spring. The Amish are not just using these fridges because they are off-grid. They are using them because they figured out decades ago that a single propane flame burning 24 hours a day cost them less in a year than I was paying General Electric in a single month. Mervin pulled out his ledger. Handwritten, in pencil. His total propane cost for refrigeration in 2023 was $78.40. Mine was over $600. And his fridge was built in 1978. It has been running without a single repair for 46 years. Now think about that. 46 years. My last fridge died at year 9. The repairman told me it was cheaper to buy a new one, so I did. And then that one died at year 7. We have been trained to accept appliances that fail on a schedule. The Amish refused to accept that bargain. They kept the old technology. the technology that works. And here is where the story gets darker. Because once you understand the absorption fridge exists, you start asking why your father never had one, why your neighbor does not have one, why the appliance store does not carry one. The answer is not that the technology failed. The technology never failed. It was buried. Buried by an industry that figured out sometime around 1947 that selling a man one fridge for life was a terrible business model. Selling him 8 fridges over his lifetime was a much better one. So they advertised, they lobbied, they pushed, and the flame-driven fridge got pushed out to the edges where only the Amish, the truckers, and the cabin owners ever saw one. There is more to this story, and the next part is the part the gas utility companies do not want anybody to figure out. Because that one tiny flame, it does not even have to run on propane. I want to tell you about a man named John Stoltzfus. He was an old order Amish bishop in Lancaster County, and in 1969, he wrote a letter that ended up in the archives of the Young Center for Anabaptist and Pietist Studies at Elizabethtown College. The letter was about technology, about what to accept, what to refuse, and in it, he said something that has stuck with me since I read it. We do not refuse the electric because we fear it. We refuse it because it makes us forget how the world actually works. That sentence hit me like a hammer, because I had forgotten. I had forgotten that cold is not something you buy from a wall socket. Cold is a physical process. Heat moves, pressure changes. Molecules absorb and release energy. The Amish never forgot. They kept the knowledge alive on purpose. And the absorption fridge, that quiet flame system, was one of the things they preserved. Now here is the practical part, because I know what you are thinking. You are thinking, all right, this sounds great, but I am not Amish. I have a regular house, I have a regular kitchen, and I am not about to rip out my walls. Stay with me, because what I learned next changes everything. These absorption refrigerators are still being built, right now, today, by Amish craftsmen in Pennsylvania and Ohio. The most common brand is built by a cooperative in Lancaster County that has been producing them since the 1950s. A full-size unit, comparable to your standard kitchen fridge, runs between $2,000 and $3,000 new. Used units in working condition regularly sell for under $800. They run on propane, they run on natural gas. Some of the older models, the ones from the 1930s, even run on kerosene. And here is the wild part. Some of them can run on 3 different fuels, switching back and forth depending on what is available. A single 20-pound propane tank, the same tank you use for your backyard grill, will run one of these refrigerators for about 3 weeks. 3 weeks of continuous 24-hour cooling on a tank that costs you about $22 to fill. Do the math. That is roughly $400 a year for refrigeration. If your home is hooked up to natural gas, the number drops to under $100 a year. And if the grid goes down, ice storm, hurricane, summer blackout, whatever it is, your food stays cold forever, as long as you have fuel. This is the part the prepper crowd has known for years but never quite explained to the rest of us. When the lights go out, the Amish fridge does not care. There is no inverter to fail, no battery to drain, no solar panel to clean, just the flame. And the flame does not know there is a hurricane outside. Now, there is something the manuals never tell you, and I learned this from a man in Strasburg, Pennsylvania, who has been repairing these units for 38 years. He said, the absorption fridge has one weakness, and it is also its greatest strength. It must be perfectly level, within a 1/4 inch over the entire cabinet. If it tilts more than that, the liquid ammonia pools incorrectly, and the cooling cycle slows down. That is why the Amish set these units on solid stone or thick hardwood floors, never on linoleum, never on anything that flexes, but once you level it correctly, that fridge will outlive you. The repairman told me he has serviced units from 1,952 that are still pulling food down to 34 degrees on a hot August afternoon. Now, if you already own a house and you are thinking this only applies to people building from scratch, stay with me, because this next part is specifically for you. I want you to walk into your kitchen tomorrow morning and look at the wall behind your current refrigerator. In 9 out of 10 American homes built before 1980, there is a gas line within 12 feet of that wall. Maybe it feeds your stove, maybe it feeds your water heater, maybe it is an old capped line from when the previous owner had a gas dryer. That line is your starting point. An absorption refrigerator does not need a special hookup. It needs a 1/4-inch flex line, the same kind that feeds your gas stove. A licensed plumber can run that line in about 3 hours. Most homeowners I know have done it themselves with a basic plumbing kit from the hardware store and a soap water test for leaks. The total cost of the line and the fittings is under $60. The total install time, if you are doing it yourself on a Saturday morning, is 1 afternoon. You do not need to remodel, you do not need new wiring. In fact, you can unplug the wiring you have. The space your current fridge occupies is more than enough for a standard absorption unit. They come in nearly identical dimensions, 28 inches wide, 65 inches tall, same shelves, same crisper drawers, same ice maker on the higher end models. The only difference is the small vent at the back where the warm exhaust escapes and a small flame chamber at the bottom that you will never see and rarely think about. Mervin told me his wife has never had to defrost their fridge, not once in 46 years. Because absorption fridges run at a much more consistent temperature than compressor fridges, there is no on-off cycle. The flame burns steady, the cold stays steady. Frost does not build up the way it does in your unit, which kicks on and off every 8 minutes and creates those little temperature swings that grow ice crystals on your peas. The food lasts longer too. A gallon of raw milk in Mervin's fridge stayed fresh for 19 days. Try that in your kitchen. But there is something else I need to tell you. Something I almost missed. When I was sitting at Mervin's table, his grandson, a boy of about 11, brought in a small wooden box from the spring house out back. Inside that box were 3 glass jars. Butter, cream, and a cut of cured pork. The boy said, "Grandpa, the spring house is doing the heavy work this month. We don't need to keep these in the kitchen." And Mervin nodded and smiled at me and said, "That's the real secret. The fridge is just the backup." I did not understand at first, but what he meant was this. The Amish do not rely on the absorption fridge alone. They use it as one tool in a system. The spring house, the root cellar, the ice house, and the absorption fridge work together. The fridge handles the things that need consistent cold year-round: the dairy, the eggs, the leftovers. The cellar handles the root vegetables and the canned goods. The spring house handles the butter and the cream in summer. The ice house handles the meat in winter. The flame only has to do a fraction of the work because the rest of the system is doing its part. That is why their fuel bills are so low. That is why one 20-pound propane tank lasts 3 weeks. The fridge is not fighting the whole kitchen on its own. It is supported by 100 other small decisions that the modern American home threw away sometime around 1955. And here is the layer most people never reach. The Amish do not keep their fridge in the warmest part of the kitchen. They keep it in the coldest part. Usually a north-facing wall, away from the cook stove, away from direct sunlight. American kitchens are designed around the cook's convenience: fridge next to the stove, dishwasher next to the sink, microwave above the range. The Amish designed around physics. Cold equipment goes in cold corners, hot equipment goes in hot corners, never the two shall meet. By moving the fridge to the coolest wall in your kitchen, you can reduce its workload by as much as 18%. That alone, on your current electric fridge, would save you about $90 a year. Before I show you what Maria Telkes documented in 1947 at MIT, one quick thing. Everything I have been digging out of these Amish kitchens and old patent archives, the single blue flame burning since 1922, the absorption fridge that runs on $7 a month of propane, the 20-pound tank that lasts 3 weeks, the 1/4-inch flex line install for under $60 on a Saturday morning, the spring house plus root cellar plus ice house system that lets the fridge handle a fraction of the work, the trick of putting cold equipment in the coldest corner of the kitchen, the cellar vent I am about to walk you through, the $50 wall from the Trombe wall video, the Burkholder reservoir from the sand battery video, the smoke shelf from the Hans Herr video, the breath line from the $8 fix video, and all the other pieces I have pulled out of Lancaster County and Holmes County over the years. I have put it all in one place, room by room, season by season, in the order the families actually use it. It is called the Amish Home System. Link is in the description. But stay right here, because what Maria Telkes documented in 1947 is the $40 weekend project that lets your basement do half the work of your refrigerator forever. But the absorption fridge is only half of the secret. There is one more piece I have been holding back, and it is the piece that ties this whole thing together. The piece that, when I learned it, I sat in my truck in the gravel driveway for 10 minutes just shaking my head. In 1947, a U.S. Department of Agriculture researcher named Dr. Maria Telkes, a Hungarian-born physicist working out of the Massachusetts Institute of Technology, published a paper on what she called passive thermal storage. She was not researching refrigerators, she was researching solar heating. But buried in her paper, on page 41, was a paragraph that almost nobody read. She described how a sealed clay vessel filled with cold spring water and buried 2 feet below the floor of an insulated room could maintain a temperature of 42 degrees Fahrenheit for up to 11 months, without any fuel, without any electricity, without any flame at all. She called it the cold sink principle. The Earth, below 2 feet of depth, holds a constant temperature of about 52 degrees Fahrenheit year-round in most of the United States. If you trap that cold air against an insulated chamber and channel it upward, you can use it to keep food cold using nothing but the planet itself. The Amish, in their most conservative communities, have been doing exactly this for over 200 years. They called it the cellar vent. A small wooden duct, no bigger than a shoebox in cross-section, running from the floor of the root cellar up through the back of the kitchen pantry. The cool air from the cellar rises into a small insulated cabinet about the size of a modern dishwasher and keeps butter, eggs, cheese, and milk at a steady 43 degrees all summer long. Zero fuel, zero flame, zero cost. Here is the part that broke me. When I asked Mervin's father, an 87-year-old man named Amish who still chops his own firewood, why this method was never taught in the wider world, he looked at me with watery blue eyes and said, "Because there is no bill to send." There is no bill to send. That is the whole story, right there. You cannot charge a man a monthly fee for using the temperature of his own dirt. You cannot meter the cold of the earth beneath his feet. You cannot patent the natural convection of cool air rising into a properly insulated box. So the knowledge was allowed to fade. The cellar vent disappeared from American home design somewhere between 1948 and 1962, replaced by the all-electric kitchen that the utility companies aggressively promoted with their Live Better Electrically campaign. Look it up. That campaign was funded jointly by General Electric, Westinghouse, and the Edison Electric Institute. Their explicit goal, stated in their 1956 industry report, was to increase residential electricity consumption by 300% over 20 years. They succeeded, and the cellar vent went into the grave, but the Amish never let it go. And here is how you can rebuild it in your existing home this weekend with under $40 in materials. You need a basement or a crawl space. Almost every American home built before 1990 has one. You need a 6-inch insulated duct, the kind sold in any hardware store for about $18. You need a small wooden cabinet. An old pantry shelf works fine, lined with 1 inch of rigid foam insulation. You drill a single hole through the floor of your pantry, run the duct down into the cool air of your basement, and seal the top with a simple gravity damper that opens when warm air rises out of the cabinet and closes when it does not. That is it. That is the entire system. The cool air from your basement, which sits between 48 and 56 degrees year-round, rises naturally into the insulated cabinet by convection. The warm air inside the cabinet is pushed out the top. The cycle is self-sustaining. There is no flame, there is no electricity, there is no fuel. The earth does the work. I built one in my own pantry 6 months ago. I keep butter, cheese, eggs, and a jug of milk in it. The temperature stays between 41 and 45 degrees, 24 hours a day, 365 days a year. My electric bill dropped by $22 a month because my main fridge is now doing about half the work it used to do. $22 a month, $264 a year, from a $40 weekend project. And when I combine the cellar vent with a small absorption fridge for the items that need to be colder than meat, the leftovers, my total refrigeration cost is now under $120 a year, down from over $700. The Amish were right, the Earth was right, Baltzar von Platen was right, Maria Telkes was right, and the people who told you that you needed to plug a 1,000-watt machine into the wall to keep a stick of butter cold were selling you something. You did not lose this knowledge by accident. It was taken from you. And tonight, sitting in front of this screen, you took a piece of it back. If you are the kind of man who believes that real knowledge has been quietly pushed aside to protect somebody else's quarterly profit, then you already know what to do next. You know that the answer was never in the appliance store. The answer was in the dirt beneath your house, in the patent filed in 1922, in the letter written by a bishop in 1969, and in the quiet flame burning behind a wooden cabinet in a kitchen in Holmes County, Ohio. I want to hear from you. Specifically, I want to know, when you look at your current refrigerator, the one humming in your kitchen right now, how old is it, and how many times have you had to replace it in your lifetime? Drop that number in the comments below. I want to see it. I read every single one. And when you see how many other men have replaced 4, 5, even 6 fridges in their lifetime, you are going to understand exactly how big this con has been. If this is the first time you have heard the names Baltzar von Platen or Maria Telkes, you are not alone. There are dozens more like them. Men and women who built real, working systems that the industries buried because they could not be metered. On this channel, we dig them up one by one. We bring the knowledge back to the people who should have inherited it from their grandfathers. Hit subscribe and join the movement of men who are taking back what was taken from us. And in the next video, I am going to show you the Amish water system that pumps fresh, cold water through an entire farmhouse using nothing but a single ram pump invented in 1796, and how you can install one in your existing well for under $200. You are not going to believe what they did with a pipe, a check valve, and a hill. I will see you there.